Hello everyone, my name is Valentin Toby. I'm a security architect with F5, and today I will present a short demo on how to use F5 distributed cloud app infrastructure protection to block the exfiltration stage of a cyber attack. Distributed cloud AIP is protecting cloud-native applications and their infrastructure by providing full-stack visibility, machine learning-enabled threat detection, and integration with customer SIEMs or platforms for threat response. For the purpose of this demo, we will use Distributed Cloud AIP integrated with STIR, an open-source project developed under the Innovate F5 program. Specifically, we will be using the Hive case management system and Node-RED automation tool components of STIR. Let's take a quick look at the setup we will use. We have a web server deployed on a public cloud, in this case AWS, and exposed to the internet through F5 distributed cloud platform. So the client connections will be going through an F5 distributed cloud load balancer, then through an F5 distributed cloud AWS VPC site, and then to the web server. Any outbound connections originating from the web server will have to go through the same distributed cloud AWS site. We will examine the case where, due to a malicious insider action, a PHP script has been dropped on the web server, where it is periodically collecting information and trying to exfiltrate them by connecting to a server on the internet under the attacker's control. For the purpose of this demo, I will use an ELK instance that will allow us to see the exfiltration data being received by the attacker. On the web server, we have an AIP agent that sends telemetry data to the cloud-based AIP dashboard, which in turn sends security alerts to the Hive, where they are converted to cases for management during the investigation performed by the SecOps team to determine if the alert is true or false positive. In this case, alerts are converted to cases automatically by Node-RED. Once the security analyst has finished the investigation and has marked the case as a true positive, there is an option to add threat response actions to be taken by Node-RED on the F5 distributed cloud platform. In this case, to block the outgoing connection at the distributed cloud AWS site level. If you want to know more information about the components used in this demo, you can read a companion DevCentral article. I will drop a link in the description below. So let's quickly run through the demo. Here we can see the exfiltrated data reaching on the attacker server. You will notice the script runs every minute and gets the list of processes that run on the web server under attack. These outgoing connections are being detected by AIP. Here you can see the AIP dashboard and the alerts it generates. AIP is integrated with the Hive, so the alerts are automatically pushed there. Here is a view of the Hive's alert dashboard, and we can see the alerts sourced by AIP. We are using a Node-RED flow to automatically convert it to a case, which we can see on the cases dashboard. We can take a look at what a Hive case looks like. We can see the description of the AIP event that triggered this alert and the destination of the outgoing connection, which is our attacker server. We can start investigating this case and can assign tasks to our SecOps team, analyze the observables, in this case just the destination IP address, and tag the case with the tactics, techniques, and procedures we uncover. Let's say that after our investigation, we decide this is indeed an exfiltration attempt, so we will want to close the case as a true positive. But before that, we want to tag it with the response action we want to carry out. In this case, the action is to block the destination IP, and the location is the distributed cloud AWS site that front-ends the web server. Once the case has been closed, Node-RED starts a flow that checks if the case status has been updated, if it was marked as a true positive, and if it has the response actions to be carried out on the distributed cloud platform. Once these actions are carried out, we can see a network firewall policy being added or updated on the distributed cloud console, and the policy rule being added specifying the case number and the blocking action taken on the destination IP. We can check again the attacker server, and we can see it has stopped receiving exfiltrated data, as these connections are now being blocked on the AWS site level on the F5 distributed cloud platform. This is all I had for today. Thank you for your attention.